Find the locus of points px comma y such that the distance of p from p1 1 comma 1 is 1/2 the distance of p from p2 -2 comma -2. So basically what we must do, we must find the described conditions in such a way that 1/2 the distance from p to p2 is going to be the distance from P to P1. Okay? So this reflects mathematically what's being described here. So the locus of points is going to be the list of points satisfying the given condition that we just used in the equation. So now, we're going to use the distance formula. So we know that 1/2, so we need to find the distance from P to P2. So P has X and Y and P2 has -2, -2. Right, so we know X, this X, minus -2 for the P2 squared, right, plus Y minus -2 also squared. Okay, and that should equal to the distance from P to P1. So that's going to be X minus P1 is here, right? So -1 squared plus Y minus 1 squared. Okay. So now we need to square both sides. So if you square both sides, you're going to have this 1/4, right? Every individual part is squared, right? The square root is squared and also 1/2 is squared. And remember that 1/2 multiplied everything together. So you must still put parentheses, and I would use brackets in this case, and write it like x plus 2 being squared plus y plus 2 being squared, okay? Because 1/4 multiplies everything together like 1/2 did the contents inside the square root. And that's equal to, since we're squaring both sides, the square root on the right side is also gone, right? So that's going to be x minus 1 squared plus y minus 1 squared. Okay, now that we have that, we can go ahead and expand things. So we know the left side is going to be 1/4 times x squared plus 2x plus 4, and that stands for, this trinomial is for the binomial being squared here, plus y squared plus 4y plus 4. Okay, that stands for the trinomial, for the binomial being squared, which gives us this trinomial. Now minus, now why am I doing the minus? Well, I'm subtracting this from both sides, and I'm also subtracting this from both sides. Okay. I'm subtracting both of these terms from both sides. So if you subtract this one, it's going to give you x squared minus 2x plus 1, and I'm just expanding this being squared. And then minus, and this thing is going to be what? Y squared minus 2y plus 1. Okay, and now it doesn't need to be squared anymore, so that's equal to 0. So next we're going to multiply both sides of the equation by 4 to get rid of this fraction. Right, so we're going to essentially multiply both sides by 4. So what happens is the 4 will be cancelled out as a result. This thing will be multiplied by 4, this term will be multiplied by 4, and 0 times 4 is still 0. Right, so what that gives us is x squared plus 4x plus 4, and I don't know why I wrote 2x before. This should be a 4. So 4, okay, 4 plus y squared plus 4y plus 4. And then minus, now 4 will be multiplied to this, right? So minus 4x squared minus 2x plus 1 minus 4 times y squared minus 2y plus 1 is equal to 0, right? 4 times 0 is still 0. So simplifying this would give us what? X squared plus 4x plus 4 plus y squared plus 4y plus 4 minus 4x squared plus 8x minus 4 minus 4y squared plus 8y minus 4 is equal to 0. So now you have to combine like terms. As you can see, we have this one and this one. We also have these. Okay, we also have the y squared. Okay, we also have the y's, and we finally have the constants, right? These numbers. Okay, so keeping that all in mind, x squared minus 4x squared is minus 3x squared. 4x plus 8x is 12x. Let's talk about the y squared. So y squared minus 4y squared is minus 3y squared. And then the y's will be what? 4y plus 8y. So that's 12y. And the constants, let's see, 4 plus 4 minus 4 minus 4. So that's 0, no constants. So now what is this going to be? We have to still simplify this, right? So you want to divide both sides by negative 3. Notice all of these coefficients are divisible by negative 3, which is good. So what we get as a result is x squared minus 4x plus y squared minus 4y is equal to 0. Okay, so this is what we get. And we can reorder these terms. We can write them as x squared plus y squared, and then minus 4x minus 4y is equal to 0. So notice that if we were trying to graph this, let's say if we were trying to see how this works graphically, and we try to visualize what is being talked about here. So we have these points, respective points. We need 1, 1. We need negative 2, negative 2. Okay, so we were talking about these points. Negative 2 is here, and 1, 1 is here. Notice that this distance from here to here is exactly 1/2 the distance from this point to the origin. Okay? And how do I know that? I can visually see that because I have components 1 and 1 here, but I have components 2 and 2 here, right? 2 and 2. So using direct proportion, you know that the hypotenuses, these lengths, these resulting lengths using the components will also be having the same ratio, right? So this is going to be 1, this is going to be twice that, right? This is going to be 2, for example. I'm not saying this is 1, but I'm saying if this has a unit length 1, this has a unit length 2. Now, how do I know that this is a circle equation? Well, I see that the x and y are both being squared, they're being added, but also the way to tell that this is not an ellipse is the fact that these coefficients of the x and y to the first powers, these coefficients are the same, -4 and -4. Right? So you definitely know when you complete the square, you will have an equation of a circle. So this equation of a circle tells you that the locus of points satisfying the given conditions will be the circle, and this point, the origin here, that makes the condition satisfied, is going to be on the circle, right? So it makes sense that we can call this a circle. This locus of points is a circle that passes through the origin. And lastly, notice that algebraically you also can confirm that an origin is a point on that circle because origin has points 0, 0. And if you plug in 0 for the x and 0 for the y, notice that everything on the left side would turn to 0, which makes sense with the right sign being 0. Okay? So thank you so much for watching, and see you in the next videos.